Van Gogh's Starry Night is often analysed from a mathematical perspective because of the patterns of turbulence and flow that appear in the painting. The painting's swirling skies and flowing forms resemble features of fluid dynamics and turbulence. Here's a breakdown of the math behind it. The swirls in Starry Night mimic patterns found in turbulent fluid flows, which are described by complex mathematical equations. Kolmogorov's theory of turbulence, from 1941, explains the energy distribution in turbulent systems. It predicts how energy cascades from large scales or big swirls to smaller scales or smaller eddies. Van Gogh's depiction of light and swirling clouds visually captures these patterns, as shown in studies where the painting's luminance or brightness is analysed. Remarkably, the intensity gradients match mathematical models of turbulence. Mathematicians and physicists analysed the luminance field in Starry Night, which refers to the variation in brightness across the painting. Using Fourier analysis, researchers discovered that the brightness fluctuations in Starry Night align with the same statistical properties seen in turbulent flows. For example, the interplay of light and shadow around the stars creates a dynamic sense of motion, echoing the energy transfer seen in natural turbulence. The spirals in Starry Night, like the large swirling patterns in the sky, resemble logarithmic spirals, which are quite common in nature, such as in galaxies, hurricanes, and seashells. These spirals are described by equations like r equals ae to the power of b theta. While Van Gogh likely didn't use this equation directly, the visual similarity to such spirals hints at an intuitive understanding of these natural forms. The self-similar patterns in the painting, like swirls within swirls, have fractal-like qualities which are common in turbulent systems. Fractals are geometric shapes that repeat at different scales, described mathematically by equations like z sub n plus 1 equals z sub n squared plus c. Van Gogh's use of contrasting colors like blues, yellows, and whites emphasizes the motion and energy of the scene. While not directly mathematical, the human perception of contrast enhances our ability to see the patterns of flow and turbulence in the painting. In conclusion, Van Gogh's Starry Night captures a deep mathematical truth about the world. The painting's resemblance to the equations of turbulence and natural flows demonstrates how art can intuitively reflect complex scientific phenomena, blending creativity with mathematics.